Well, howdy, and welcome to Dividing Polynomials Part 2, and we're going to look at something called synthetic division. It's kind of an easier shorthand way of doing the long division of polynomials, and it's a pretty handy little method. But first of all, let me just show you when it works. So it doesn't work all the time. It works for a situation like this, where you have some sort of a lengthy polynomial function, and then you're going to divide it by some kind of binomial, meaning you have something like this, x minus or plus a number. Okay, so this is the important restriction here, this guy here. You'll notice there's no number in front of x. Okay, so it only works when you've got this form. For example, maybe you're dividing by x minus 7, okay? So that would be good. Or maybe you're dividing by x plus 4, okay? That would be fine. Or even you could use fractions and do something like that. That's all good. But what you can't have is a number in front of x, and you can't have more than the two terms. It has to be x plus or minus some kind of number. And then this method of synthetic division works. Okay, let me show you what we're going to do here. And at first it's going to seem really strange to remember all the steps. It's just a different way of doing long division. So I'm going to clear the screen and show you an example. So suppose we had something like this. Say we wanted to do, so first example here, say you wanted to do x plus 1, and you were going to divide that into x cubed plus x squared minus 4x minus 4. Now this is set up for long division, but this is the kind of question I would be trying to do. And I look at this and I go, well, there's nothing in front of x, and then I'm tacking on a number. That's perfect for synthetic division. So here's how we set it up for synthetic division. We kind of flip the little division framework, and we flip it over actually. And then what we do is we write out the coefficients of your dividend here. The polynomial p of x kind of goes in this location here, but you only write the coefficients. So I look at this and I go x cubed, well, there's one of those. X squared, there's one of those. The x term, there's a negative 4 in front. And then my constant at the end is negative 4. Okay. Notice I didn't miss any. It's really important that you remember that this was the coefficient for x cubed, then came x squared, then came x, and then came the constant. Okay. If they're not there, you got to put in a 0. Okay. Then we bring this 1 here, our starting term, and we write it at the bottom. Now we've got to put a number out here that we're going to divide into this. And what you do is you look at your divisor and you figure out, well, what value of x makes this thing turn to 0? And that value is negative 1 in this example. Now I'm ready to do my division. So I go 1 times negative 1, and I write it here as negative 1. And then I add them together. So I get 1 plus negative 1. Well, that's 0. Then I repeat, 0 times negative 1, which is 0. And then I add these numbers together, and I get negative 4. Then I go negative 4 times negative 1 is positive 4. And then I add these numbers together, and I get 0. Well, guess what? We just did the long division, and here's our answer. This is our quotient. Okay, quotient meaning the answer after the division. Now, it doesn't look like much of an answer, but let me explain what we actually have here. Okay, when we started, this was what we call a third degree polynomial, meaning the highest power of x is x cubed. So in your answer, you knock it down one level. These are the coefficients, and what we now have is 1x squared, 0 x's, and then our constant is minus 4. And this here is our remainder. Okay? So in other words, what we've accomplished here is this. when we took x cubed plus x squared minus 4x minus 4, and we divided it by x plus 1, the quotient, or the answer, is x squared minus 4. And the remainder, which we usually add on, in this case happens to be 0. So, by the way, this is the old division statement in action here, but it really shows you what we've accomplished, which is the same long division without all the long division work. You know, it didn't go on and on and on. We just went boop, 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 and there's our answer. So it is a much more quick way of doing things. Okay. All right. I guess we're ready for my last example at this time. So I'm going to clear the screen here and see if you agree that this is a better way of doing long division. So we're going to take the question 2x to the 4th plus 5x minus 6x cubed minus 8. We want to take that and we want to divide it by x minus 3. And so I go, oh, this guy here, the divisor here, it is of that correct form of x plus or minus a number. So that makes me say yes to using synthetic division. You know, it's really based on this divisor. So I'm going to go right into synthetic division. So I build up the frame. And I'm dividing by x minus 3. So what I want to do is plug in the number that makes that turn to 0, right? You plug in positive 3, you get 0. So that's what I'm dividing by. And now I've got to write all these terms. And this is a 4th degree polynomial because there's an x to the 4. So I'm going to start off with the x to the 4 term, which is got a coefficient of 2. But I've got to make sure these are in descending order and that they are complete. So that was x to the 4. The next one would be x cubed. So now I'm going to write negative 6. That was x cubed. Now comes x squared, and I don't see any x squared. So I'm going to put in 0. Then comes x, which has a positive 5. And after x comes the constant, which is negative 8. Okay, so there it is. And I'm going to bring down my first coefficient, and then I'm off and running. So now I just go 2 times 3 is 6, and I add them up, which gives me 0. 0 times 3 is 0, and I add them up, which gives me another 0. 0 times 3 is 0, and I add them up, which gives me 5. And 5 times 3 is 15, and I add these up. So guess what? We have finished doing our division. So I'm now going to write out the answer, and I might as well, you know, I'm going to say, well, what is the quotient? What does it actually look like? And then I'm going to write the division statement underneath it here. So remember that our dividend here, okay, the polynomial we're dividing into is 4th degree, which means this has to start off with an x cubed. It's 1 degree less. Then there's 0x squareds, 0 x's, and then the constant would be positive 5. And then here's my remainder of 7. So there it is. There's my answer. So now what would the division statement look like? Well, it basically says this polynomial, and I might as well leave it in this sort of jumbled order. Doesn't really matter. Just making a statement here that that is equal to x minus 3, okay, my divisor, times my quotient, my answer, which is 2x cubed plus 5, and plus the remainder. And so there's my division statement, which kind of lays it all out. So that's where I'm going to stop right now.